All right, guys, we're going to do a little review for test two. Test one had a lot of some really good grades and some really bad grades. So I want to give a little review, basically trying to get the bugs out for this one. All right, so everyone can do well. So if I asked you, how much does a 60 kilogram person weigh, right? Well, what is weight? Weight is the force of gravity on you. So it's F equals ma, all right? 60 kilograms times 9.81 meters per second squared, all right? And 60 times 9.81 would be 588.6 newtons. Okay, that would be the weight. Sometimes we write F sub g as weight, or we use capital W as weight. All right, they're all measured in newtons, and it has to deal with the Earth's gravitational pull on the object. Okay, now let's take this person and put him on an elevator. All right, standing on a scale, okay? And if the elevator is accelerating up, they're going to weigh more, all right? So you're going to weigh more. If it's accelerating down, they're going to weigh less, okay? If you think about it, every time you've ever ridden an elevator, when it accelerates upwards, so when it starts to go up, all right, you feel heavier. And when it stops going down, all right, like the braking, you feel heavier. Those are the only two times you feel heavier. If when it's moving at constant speed, you feel the same, okay? And then when it's accelerating downward, all right, you'll feel lighter. So you have to look. You say, okay, now let's say we're accelerating up at 2.5 meters per second squared, okay? So now apparent weight would be F equals m, and then it would be g plus or minus a. It would be plus if it's accelerating up, it's minus if it goes down. In this case, we're accelerating upward. It would be the mass would be 60 kilograms times 9.81 plus 2.5 meters per second squared. All right, let me make sure you can see that. All right, and we've got 60 times 9.81 plus 2.5, and that gives us 738.6 newtons. All right. All right. So if you're on an elevator accelerating up, you weigh more. All right, and you add the acceleration of the elevator to that. If I asked you if you're accelerating down, you'd subtract the 2.5, and they would weigh basically the difference less. Okay. All right. Now we're going to go to the Atwood machine. You have a pulley, you have two things. Let's say we have 25 grams here and we have 20 grams here. Okay, this side's heavier than this side. It will accelerate downward. Okay, let's say we're going to go 3 meters. Okay, and it's going to take, let's see, 8 seconds. All right, I'm just making these numbers up off the top of my head, so I have no idea what we're going to come up with. Now, if we look at D equals 1/2 AT squared, your D is 3 meters, 1/2 A 3 seconds, or 8 seconds, 8 seconds squared. All right, if you plug that in, you got 64 times 1/2. All right, and then you have 3 over that, and the acceleration comes out to be 0.9375 meters per second squared. All right. Now, when we use the Atwood formula, we have acceleration equals gravity m1 minus m2 over m1 plus m2. This is the acceleration. This is going down. It's accelerating at 0.9375 meters per second squared. Gravity is what we're looking for. And then mass 1 would be 25 minus 20 over 25 plus 20, all grams. And this, if it's grams or kilograms, it doesn't matter, right? Because we're looking at the difference here, okay? So this would be 5 over 45 times gravity equals 0.9375. So 5 over 45 is 0.11. So I would divide the 0.11 over. So I have 0.9375 divided by 0.1. And I get gravity to be 8.44 meters per second squared. So that's how you can use the Atwood machine to calculate gravity. Okay? Okay, next one. We're going to look at a object on an incline. Okay? All right, we've got a box sitting on an incline. All right. Let's throw a 30-degree angle in here, and we'll throw a box, and we'll call it, let's say, 50 kilograms. All right. Now, what pulls it down the ramp? Gravity, right? But gravity's straight down, but it's going this way, okay? So we call this F parallel. So force parallel to the surface pulling it down. And F parallel is equal to the mass times gravity times the cosine, nope, sorry, cosine, that'll be sine. Because if it's at 0, sine of 0 is 0. Yes. Sine of the angle. All right. So this one would be 50 kg times 9.81 times sine of 30 degrees. Now this scenario was actually Galileo Galilei actually used a ramp and rolled balls down, and he used a pendulum to time the ball to figure out what the acceleration was, and from doing that and using the sine of the angle, he was actually able to calculate gravity pretty accurately. And this was done really long time ago. All right, so we got 50 times 9.81 times sine of 30, and we get 245.25 newtons. So the force pulling it down the ramp is 245.25 newtons. Now, if it's moving at constant speed, then the forces have to be balanced. What force has to be balanced? Upward would be the force of friction. So if it's moving at constant speed, and I asked you, what is the force of friction of this? You just find F parallel, and it's 245, well, that's pretty sloppy, 0.25 newtons, okay? And it's up the ramp, all right? Now, if I asked you for the normal force, all right? The normal force is the restorative force based on the surface here, and that is equal to mg cosine theta. So it's 50, 9.81, and cosine 30. And so 50 times 9.81 times cosine 30, and we get 424.78 newtons. Okay? So the normal force would be that. Now the normal force is also called the F perpendicular, sorry, F parallel. Perpendicular force. Okay, it's also called the perpendicular force because it's perpendicular to the surface. Okay, if you were to draw this drawing to scale with like 1 centimeter equals 100 newtons, okay, basically what you do is you draw your F parallel, you would draw force of gravity straight down. And then this right here would be F perpendicular, all right, or F normal force. Or sorry, yeah. This is how they would actually interact, okay? And then this angle here would be 30 degrees as well, okay? Opposite interiors, okay? So I'm going to ask you on an incline, I'm going to ask you for either parallel or the normal force or the perpendicular force or the force of friction, any of those things. And it's all based on this drawing, okay? So make sure you know how to do that. All right, next one here. Okay, so I've got a box, let's say it's 50 kilograms again, let's say it's 30 degrees, and it's just sitting there, okay? And I ask you, what is the coefficient of friction? Well, force of friction equals mu F of n, okay? And we are looking for the coefficient, we're looking for this. Now, if it's just sitting there, that means F parallel is equal to F force of friction, all right? So this would be the same thing as F parallel. So this is mg sine theta times mu, and the normal force is mg cosine theta. So if I solve for this, and I divide mg cosine theta over, the mg's cancel out, and sine over cosine is tangent. So tangent of 30 is 0.577. That is the coefficient of friction of this object sitting on this surface. Okay, just easy trick, okay? All right. Next one. All right, I've got a box being pushed across the floor. I'm going to give you the weight of the box. So let's say it's 300 newtons. I'm going to give you the static friction coefficient. So coefficient of static, we'll say it's 0.7. And I ask you, what is the force necessary to get the object to move? So that's F of F equals mu F of N. F of N is 300. Remember, force is in newtons. This is in newtons. We're good to go. 300 newtons. Mu 0.7. And we get 210 newtons. That's our force of friction. So that is the force necessary to get this to move. Okay. All right, next one. Okay, we got a car moving, all right, a car moving at 20 meters per second, okay, and he slams on his brakes and he slides to a stop. Okay, so this is VI, and then VF is 0, and the coefficient of friction, we're going to say, is 0.75, all right, for a sliding friction, so that would be kinetic, all right, and the question asks, how far does he slide, okay? So the first thing we have to do is we have to figure out the force involved here, all right? And we want to figure out how far it goes. So we have a coefficient of friction, and oh, I forgot the weight of the car. All right, so that is a 800 kilogram car, okay? So F of F equals mu F of N. We have 0.75 times the weight, 800 times 9.81. Remember, kilograms is not newtons. You have to multiply by gravity to get newtons. Okay? So 0.75 times 9.81 times 800. All right. 5886 newtons is the force. Okay? Now we know that the force, now we can do F equals ma. All right? So 5886 newtons equals 800. And we're looking for the deceleration here. This is actually it's a force of friction, so it's negative actually. So it's a negative. Okay. So that divided by 800 gives a deceleration of 7.36 meters per second squared. Now we can go back to our kinematics formula. Vf squared equals Vi squared plus 2AD. Final velocity, 0. Initial velocity, 20. That's squared plus 2 times our acceleration is negative 7.36. Times the distance. So 20 squared is 400. So this is 400 plus 2 times 6. And negative 14.72 times D equals 0. Subtract the 400 over. Squared, second squared. Divide by negative 14. Squared. And we get D is 27.17 meters. Okay. All right. Okay, next question. We're going to talk about tension in a rope, and we are going to have a truck pulling something, and we want to find out how fast it can accelerate before it breaks. So let's say we got a truck, all right? Okay, and it is going to, let's say, 1,600 kilogram truck, and it's towing something, all right? And the rope here can only withstand 800 newtons of tension. If it goes to 801, it breaks. And we want to find the maximum acceleration of the truck. So this is just F equals ma, all right? 800, 1,600, A, and solve for A. So that's 0.5 meters per second squared. Okay, and that's all you get, all right? Nice and easy. Because newtons over kilograms is meters per second squared. Okay. All right, so next one. You've got a 40 Newton force, and it's applied to a 5 kilogram block. So you've got 40 newtons. All right, and the coefficient of friction is 0.3. We want to know how fast will the block accelerate. Okay, so F of F equals mu F of S. You have a 15 or 5 kilogram block, so that's 5 times 9.81, and our coefficient is 0.3. All right, so we got 0.3. 3 times 5 times 9.81. You got 14.715 newtons. All right. So the force of friction here is 14.715. If we're pushing with 40, all right, we're pushing with 40, that's more than 14.7, so it's going to accelerate. So 40, we'll look for our net force. Net force would be the 40 newtons, the force applied, minus the force of friction. And you get 25.285 newtons as your net force. And then you just plug that into F equals MA with your net force. So you have your 25.285. The mass is 5 kilograms. And we're looking for acceleration. So that divided by 5 is, acceleration is 5.057 meters per second squared. So if we want to find out how fast something's going to accelerate with friction present, you got to find your net force first and then calculate the acceleration. All right, so that is the review for chapters 3 and 4. And I hope everyone does really well on this test, okay? Thank you.